Hey everyone, in this video we are going to specifically talk about the glomerulus. So what is it? It is essentially just a ball of capillaries, so blood vessels, that are fed by the afferent arteriole, meaning that it is the blood that's coming into the kidney and it is going to essentially be the blood that needs to be filtered, right? So the blood that comes into the kidney needs to be filtered. From here, some really important components of this structure are the thin walls, right? So it is extremely thin and permeable, right? Which makes sense because if we're going to filter, we want to make sure that substances that we want to leave can leave, right? So permeable just means that the stuff can exit, stuff can move through it. So another thing here is that this is, for the most part, extremely passive. So what I mean by passive is your body doesn't need to use energy in order to do this filtering. It's something that is a passive reaction which requires zero energy and just happens by itself. This is really important because there is so much filtering going on. Um, we don't want to have to use our own energy to do this. So this is a passive process. It happens by itself. As we said before, about 20-25% of all cardiac output is filtered within a minute. So this right here, glomerular filtration rate, is going to be extremely high, right? Because we are constantly filtering the blood. With that said, just keep in mind, and we're going to talk about this as well in this video, whatever we filter, a lot of it's going to be reabsorbed, right? We don't want to just throw everything out of the blood because then we would just pee everything out and then we'd be constantly in need of drinking and eating to make sure we stay balanced. So most of this stuff is going to be reabsorbed. So that's something important to keep in mind. It's not just getting rid of stuff from the body, but we're going to remove and then bring back in whatever we need at the moment. Depends what our body needs. So going back to this, there are endothelium layers, which are important because these are going to allow, once again, the cells to be porous and allow substances to leave or come back into our body. We also have this Bowman's capsule. The capsule is what's going to surround the glomerulus. All right, so in other words, you're going to actually show you right here. Instead of just explaining it, here's a picture. So you can see that the glomerulus right here is the artery. And this is where all the blood is coming in and leaving. So the blood comes in through the afferent and exits through the efferent arteriole. So while it's in there, what is it in? And this is the capsule that we're talking about. So on the outside, which I'll do in blue, this is the capsule that surrounds it. And that's going to be very important. So that way the substances can leave the blood and go into this capsule where it'll travel down into the proximal convoluted tubule. So we'll talk about what this is in a second, but right now the point is you have this Bowman's capsule on the outside that is going to collect all the stuff that's exiting the blood. So there are two layers of this Bowman capsule. They're both epithelial tissues. They're both epithelium, and their job is to make sure that substances do not exit it. So going back to the picture, you can see here, we don't want the substances to do this. That's bad. We don't want them to leave. We don't want them to leave the Bowman's capsule, right? So we want to be able to hold on to it, but at the same time, the capsule has the ability to filter and to be porous enough for substances to move across it as needed. Also, if you look in here, because of these podocytes, which are one of the specialized cells that cover the arterioles, you can see these little yellow sections here all throughout, right? This is the location. These cells help us to allow for the filtrate to leave the blood. So now that we've gotten to this point, let's talk about that in case we're still, in case there's a little bit of confusion, right? Because what do you mean there's stuff leaving the blood? So let's start here at the afferent arteriole. Blood is going to enter. And when the blood enters, it has stuff in it that we don't want. It has the waste products. It's then going to travel all throughout all of the twists and turns of the glomerulus. And from here, anything we don't want in our blood, any waste products, are going to be removed. In fact, almost everything is removed here, right? Even the good stuff. So almost everything except for some of the major proteins in your red blood cells, right? So your red blood cells stay in your blood, and some of the major proteins will stay in your blood. But everything else, for the most part, is going to exit, good and bad. A great example of this would be something like cleaning out your refrigerator. This is one of the best examples that I've heard of. So if you have your refrigerator, right, and you go into it, let's say you have 10 items in your refrigerator, and some of them are no good, right? I don't even know if I count to 10. It doesn't matter. Who cares? So you have items in your refrigerator. Some are good, some are bad. The way you clean your refrigerator is you take everything out. Once you take everything out of the refrigerator, you can put everything you want back into it. So you take everything out, right? I didn't count 10, however many it is. Once you take everything out of the refrigerator, you put back in the items that you want, so that eventually your refrigerator is clean and it has only the stuff in it that you want, and all the garbage stays out. This is how this system works for your urinary system. You're going to take out pretty much everything that's good out of your refrigerator, out of your blood, and then at the end, you're going to put back in whatever you need. Because again, it all depends on what you need. Some substances are definitely leaving, but other substances you may want to keep depending on different things we're going to discuss in this video. Right. So with that said, if you have any questions, please let me know.